4.5 billion years ago, Earth was a boiling, toxic ocean of lava, constantly bombarded by high-velocity asteroids. At this stage, the planet was completely hostile to any form of life. That chaos peaked when a massive planetary body named Theia slammed into Earth, vaporizing the crust and launching flaming debris into orbit. As this diagram shows, the resulting debris ring eventually condensed into a single sphere. This new moon stabilized Earth's tilt and calmed the oceans, creating the specific orbital conditions required for biology to take hold. If that collision had happened at a slightly different angle, the moon wouldn't exist, and neither would the stable climate that allowed humanity to evolve. We owe our existence to a catastrophic accident. Yet humanity walked away from its closest neighbor almost as soon as we arrived. When Apollo 17 departed in 1972, it marked the end of deep space exploration for over half a century. NASA's strategy shifted toward low Earth orbit, focusing resources on missions just a few hundred miles above the atmosphere. For decades, the Space Shuttle and the International Space Station became the primary focus of American spaceflight, operating within the safety of Earth's magnetic field. This focus on near-Earth missions meant that the specialized engineering required for deep space survival, like high-yield radiation shielding and long-duration life support, effectively sat on the shelf for 50 years, while other technologies evolved. Other nations capitalized on this delay. Today, China is actively planning a permanent lunar base, backed by a rapidly advancing fleet of heavy-lift rockets. Returning to the moon has evolved into a strategic race for planetary prestige and permanent territory. The Artemis program has set April 2026 as the deadline for humanity's return to lunar orbit. To reach that orbit, NASA built the Space Launch System, a massive rocket generating the millions of pounds of thrust needed to escape Earth's gravity. At the top of that rocket sits the Orion spacecraft, the primary life support capsule for the mission's 4 astronauts. The crew includes Christina Koch and Victor Glover, the first woman and person of color to travel beyond low Earth orbit. They will be joined by Canadian astronaut Jeremy Hansen, signifying the expansion of the mission into an international effort. Despite the advanced hardware and historic crew, this mission is strictly prohibited from landing on the lunar surface. This raises an engineering question. Why fly for 10 days around the moon if the crew never touches the ground? The mission centers on system validation. NASA must prove life support and navigation function in deep space, transitioning systems from unverified to active status. Over the 10-day trajectory, the crew conducts constant checks, verifying survival data across the vacuum. This flyby is the strict prerequisite for Artemis III, which will attempt the first physical landing of the program. Artemis II serves as the mandatory stress test required to validate human survival in the lethal environment of deep space. The Artemis program aims to establish a permanent, enduring base on the lunar surface. This base will function as a long-term hub for habitation and resource extraction, allowing astronauts to stay for months rather than days. The moon offers a physical advantage. As this chart shows, launching from Earth requires massive energy to escape its gravity, whereas launching from the moon requires a fraction of that fuel. Utilizing this low-gravity staging ground, spacecraft can reach Mars with much higher efficiency. The Artemis program builds the physical infrastructure required to transform humanity into a multi-planetary species. 4 billion years ago, the moon was a result of a cosmic accident. Today, our return to it is a calculated strategy for the future of our civilization. The decision to abandon deep space 50 years ago was a significant historical error that stalled our progress. Artemis II represents the moment humanity corrects course, reopening the gateway to the solar system. The next decade will determine if we remain a single-planet culture or successfully push our civilization all the way to Mars.